In this demonstration, I'm going to show you how to perform the sensitivity analysis for the problem under exercise 2.1. So in exercise 2.1, we are asked to remove hydrogen from the other hydrocarbon using a flash drum, and we have actually generated the result for the base case simulation. And now we are asked to try to identify the best heat duty or the minimum heat duty required or released from the system in order to achieve the targeted product composition. So we have two criteria as mentioned earlier. One is the hydrogen mole fraction in the hydrocarbon stream. The other one is the ethylene flow rate in the hydrocarbon stream. We have to minimize the loss of ethylene to the hydrogen stream through the vapor product in the flash drum. Okay, now meaning we have to vary the heat duty and check whether we are fulfilling these two criteria or not. And then based on the varying parameters and also the results, we can identify the minimum heat duty that is released from the system. Okay. Remember, in our unit op specification just now, we have actually used vapor fraction and also pressure. Okay. In order to vary heat duty, one of the specification must be duty. So we have the heat duty from the base case simulation. So this is the heat duty. So it's about 2.13 times 10 to the power of 7 British thermal unit per hour, and the heat here is released from the system because it's with negative sign. We just copy this from the results tab under the block, and then we go to the block input. We don't use vapor fraction anymore. We would like to change it to duty. Just place it here. So we have substitute the specification of vapor fraction as duty, okay, because we need to vary duty in the sensitivity study later on. So once we have this, reset means you purge all the old simulation result, and then you run it again, or you click next and run it again. Okay, now you have the simulation results with the specification of unit op of heat duty. Okay. So done this, then we have to perform the sensitivity analysis. So go to model analysis tools, double click. So under sensitivity, double click again, then you click new. So we have S1 means sensitivity study 1. Okay, just use the default name. Okay, now you see varying tab, define tab, and also tabulate tab. So varying means you have to include the parameters that you would like to vary, which is heat duty here. Define means your target. You have two targets. One is the hydrogen mole fraction in the hydrocarbon product stream. The other one is the mole flow rate of ethylene in the hydrocarbon product stream. So under varying, just click new. So we have the first variable to specify. So I would like to close the model palette here. Okay, just close it. Of course, in order to if you close, let's say you accidentally close the model palette, you can go back to flowsheet, go to view, and then you can call out again model palette, call the model palette out again. Okay, so we go back to sensitivity study just now, close it again. Okay. Then we have to include the varying parameter, which is the heat duty. Heat duty is the heat duty of the flash drum. Flash drum is the block. Okay, it's a block, so it's a block variable. So which block? B101. Here we don't have much choice because we have only one unit op. So B101. Then the variable here is duty. right? Okay, so this is the varying parameter. So we would like to vary from, say, 1 times 10 to the power of, minus 1 times 10 to the power of 8 from the lower point to the higher point. Okay, so this is the range that we would like to vary, and the number of points, say 100. So it's up to you. You can also put 1000, but the system will need more time to generate the information for you. So once this is done, meaning all the required information for the varying parameters are completed, so it will turn blue. Okay, all done. So you shift to define, or you can even click next, or either you shift to define. So under define, I'm going to show you only one, so the other one you can test it on your own. So we are going to include the mole fraction of hydrogen mole fraction, something like this, hydrogen mole fraction. Okay, you can put any name, but make sure the name that you put don't confuse yourself. So click OK. So we know that this is a stream variable because this is the composition, the product composition. So it is mole fraction. Which stream? I think hydrogen in the hydrocarbon stream. Okay, we would like to know our liquid stream, liquid product stream. So in our liquid product stream, how much hydrogen we have in terms of mole fraction. So the component is hydrogen. So with this, let me check, S3, yes, it's the liquid. So with this, we have enough information for the define tab. So I define only one, but we are having two criteria, right? So the other one, I will leave it to you. The other one should be the ethylene flow rate in the hydrocarbon product stream. Okay. So once you have this, then you go to tabulate. So under tabulate, you don't need to do anything. You just need to fill up the variables. Okay. So we fill up the target variables. Once you click this, the targeted variables will be put under here. So if you have 2, then 2 will be listed over here. So done. So if you don't know which step to go next, then just click next and OK. Okay. Now the results are available with error. See? So why is it error? We have to go to, again, model analysis tools. Under sensitivity, we have the results. So over here, the results are with error. Okay. For the row, we have different row, different row of results, because we are varying the heat duty from minus 1 times 10 to the power of 8 to minus 1 times 10 to the power of 7. Okay. So of course, 100 points will be here. Okay, that's why 100 row, 100 row. But if you look at here, starting from, say, the row of 80, we are having the results of OK. Okay. Depending on, if we are referring to the results with OK status, then it is OK for us to ignore the error. So you have to include the other criteria, make sure the heat duty that you select, okay, the minimum heat that you need to release from the flash drum should fulfill 2 criteria. Okay. So if you look at hydrogen, so it must be, in terms of hydrogen, if you only look at one criteria, we have to introduce a heat duty of at least, we have to release the heat from the system with the quantity of at least 2.7, okay, 2.73 times 10 to the power of 7. Okay. We have to release this much, or even lower. Then you can get the hydrogen mole fraction that meet the criteria. Okay? Because if you put higher, if we release more heat, we wouldn't get. Let's say if we release 2.8 times 10 to the power of 7, then the mole fraction of hydrogen is actually more than 0.02. So this is off-spec product. So we can't go for this. We have to go 2.73 and below. That means we have to release 2.73 and below. Okay. So I think that's it for the demonstration of the sensitivity analysis. I hope you can get some hints from here to try on your own on another criteria. You have to add in another criteria and identify the heat that should be released from the system, the minimum heat that you should release from the system in order to fulfill the both criteria. So thank you very much.